We're going to simplify an expression. 6x times parentheses 2x minus 3y in the parentheses minus a y times 9x minus 4y. It looks kind of crazy in there, all right? A lot of expression going on, but what we're going to do, we're going to try to find some things that may give us some nice like terms going on, all right? So let's see where it's going to go. Let's see where it's going to go. And you know what? Right off the bat, I see parentheses and I think the big D, distributive property time, distributive property time. So let's go there. Let's go there first, all right? Let's pick it up. Let's take 6x times the first parenthesis. And you know what? There are two members there. You got to hit them both, folks. You can't just leave one, all right? You got to do them both, all right? So distributing 6x times 2x. Oh, we so much like to say that's 12x, but it's not true, not true. It is 12, but it's also x times x, which is going to give us x squared, all right? So we put our 12x squared rock and rolling right in there. We also are going to take 6x times the negative 3y here, all right? Now, x's and y's, you know, we just jam them together when we're multiplying because that's what's happening. We're multiplying here. So 6 times 3, that's going to catch us with 18. It's going to be a minus. And then, dear friends, we've got x and a y that just go along for the ride, all right? There they are, all right? So that's the first parenthesis. Now, let's take care of our second parenthesis. We have a minus y in front of that parenthesis. So what we're going to do, we're going to take this, and we got to watch our signs, because this is going to make sign changes happen, all right? So what was positive 9x is going to become a minus 9 and an x and a y. There it goes. I see something happening. I see some things are going to join together. Do you all see some things that are going to join together? Of course you do. Got like terms, and you notice those things, and you say, ooh, we can put them together. And we will in just a minute. We've got a negative y here, a basic opposite of y kind of situation, times another minus 4y here. Well, that's going to be a negative times a negative, which gives us positive. And again, don't forget to bump up that y squared when that exponent goes squaring, all right? So again, real quick check, because we want to make sure everything's right before we decide to add these like terms. We've got 6x times 2x. That's 6 times 2 gives us 12. And the x times x, remember, bump up the exponent, it's going to be x squared. Now, on our next part here, the 6x times the minus 3y, we just keep the x and y together. There's no bumping because there's no different exponents popping up with the x or the y. You just get the x, y, and keep it, all right? We've got a minus 18 and the xy attached. On our next term, again, that minus y times 9x. Man, we got a minus 9xy. And last but not least, the negative times the negative. Watch your signs. You're going to have 4y squared. You say, are we done, Ernie? Are we home free? We're close. We're close. We have these two terms right here in the middle. I mentioned they look alike. Well, they do. They have an x and a y. You say, well, the others have x's and y's, but they have to have the same exponent and the same variables. This has an x squared, whereas this has an x and a y. This one has a y squared, whereas this has an x and a y. So guess what? The two x and y's come together, and we're going to leave the 12x squared by itself because it really doesn't have anywhere to go. It's just kind of on its own. We've got a negative 18 and a negative 9. We're going to look at those. That gives us a minus 27. And this time we're just bringing them along for the ride. It's like an xy is a clump, all right? So we've got 18 clumps and 9 clumps. It's going to give us 27 of it. And watch your signs because they're both negative 18 and negative 9, which makes the final number negative 27 in the middle. As for 4y squared, hey, it just hangs out. There it is, all by its lonesome. And dear friends, we have a simplified form of what looked kind of nasty at the beginning, and some of you may say, it still don't look that pretty, but it certainly is much better than what we had at the start, all right? So we kind of have a way to corral our x's and y's together and know when to hold, know when to fold. You got to walk away at this point, all right?
For more math help, visit TNLearn.org.